There we go. There we go. There's our volume. I apologize. I don't know why I didn't go through. Volume should be there. Yes, it is. All right, whatever. Not quite sure what the story is, but ladies and gentlemen, what I have here for you guys is on my website. So, what I did yesterday, since I believe there's going to be people that need to know how to do some what? Use your calculator. Remember, we have that S portion. We went over yesterday how to do that. But what I have here, let's find it. Let's go all the way down. Let's go to the browser. So you guys can see what I'm doing. Where are you? Where are you? Where are you? There we go, I think. Was it there? Maybe we have to hit refresh. See if we have it. Yep, hit refresh. There we go. Under log cosines, I did a general worksheet here for you guys. I'll put that in the, whatever section, comment section. Okay. For those people. And what I'm going to say now, I'm going to go over to the iPad. We're going to warm up, ladies and gentlemen, on using that TI calculator. Because again, there's going to be people that can't use their calculator. So what I have here for us this morning for the S portion, like I said yesterday, we're going to do a little bit of the S supplement using our calculator. So let's read the instructions here, okay? Add some warm up here. You're going to solve for, is that in? It should be here. Whatever. Okay. There we go. You're going to solve for theta. Okay, so in every one of these here, you solve for the angle. Now, if I said to you, how do you do that? From yesterday, what did we do? You want to solve for theta. What did you guys use here? Right? What do you notice? If this is cosine, how do you get to the angle theta? Because you want to get the angle theta. Yes, you're going to use what? Inverse cosine. Is that true? And then similarly, you got sine. What do you think you're going to use here? How do we get theta if it's sine of theta? This is function notation. So how do you guys think we get theta? Inverse what? This is inverse. Remember, these are inverse functions. They're not reciprocal. So these are some inverse function keys on that calculator. And then if it's tangent, what do you guys use again? The inverse tangent key. These are inverse functions. These are not reciprocal. Okay, so it's not using cosecant, secant, cotangent. These are inverse function notation. So what I'm going to have you guys warm up this morning on is the first 8. Use your what? Use your calculator. And how are you going to approximate your answers? To the nearest what? Yeah. Well, first of all, you're going to approximate the answers to the nearest tenths, but make sure your calculator is in what mode? What mode do you want the calculator to be? In degree mode, okay? So, I mean, they didn't say that in the instructions, but I'm saying that now. So we're going to warm up here because, you know, it's a good warm up to do to be able to use your calculator. And remember this, it's not even math really. It's the calculator's doing the math. So try that out. We'll give you guys some time. And I'm going to give you guys the first 8 there to do. And we'll see how you go. This is the S. Welcome to S. Supplement. And that's not what I want. I want a clock. Okay, we'll give you guys some supplementary work to do just to use your calculator. Okay, ladies and gentlemen, let's try this out. Okay, you guys see this first question? Cosine of the angle is this number here. Okay, it is 0.867. So let me go do this. I'm going to erase this here for you guys. Okay, so what that means is by using this inverse function notation, all right, what this means by definition, you can write down the angle theta will be the inverse cosine of that 0.867. So it's a lecture on reading and using your calculator. Okay, so your angle theta now, you can get that angle theta by using your calculator, but you're going to have to use the inverse. That's an inverse. It's not a reciprocal. And, you know, the book does this to you in any trig course before they actually have you work with a lot of detail of inverse functions. Anyway, that's unfortunate, but okay. It's the way it has to be. So, okay, ladies and gentlemen, is the mode what it's supposed to be? Do we know? Let's go here. So make sure your mode is in what? Is it in degrees? Yep, it's in degrees. Okay. All right, so we're going to say inverse cosine. It's the second key. You see that cosine? That's not reciprocal. And the input is now 0.867. Close that up. And what do you guys get? What angle is this? This angle is what? We're approximating to the 10th. So it's 29.9 or 8.9. Okay, ladies and gentlemen, 29.9. And there it is. This is the angle that you're looking for. Okay, so this is kind of how we work with this. And that's the first one. So it gives us an angle, okay, working with that inverse cosine function. So what about the next one? You say, okay, well, let's see. What do we got here? All right. So for number 2, right, what do we write down for number 2? Theta will be inverse sine. That's inverse sine of, what's the decimal? 0.354. So we're going to see what theta becomes here. Okay, this is going to be for number 2 now. This is number 1. We got number 2. We want to see how to use our calculator. And, all right, so let's try this out. So second inverse sine of what number? 0.354. Close that up. And ladies and gentlemen, what's the angle again? 20 point what? 20.7 degrees. All right, so there's the angle. Okay, so now you're going to use, again, the inverse sine function on this one. So number 3, which one do you use for number 3? The inverse tangent. Okay, inverse tangent, and the decimal is 0.125. So that's the number that goes in here. Again, you're using inverse tangent to get the angle theta. And this is an exercise in using the calculator. And so, okay, second inverse tangent, 0.125, and close that. And ladies and gentlemen, what do you get now? 7.1. All right. So that angle is approximately 7.1 degrees. Okay, so that's the angle. So what do you guys think, ladies and gentlemen? Is that kind of simple? you guys know what I'm saying? Is that kind of easy peasy, or again, it's using your calculator? Okay, so you're learning even how to use that calculator to make these computations. So, I did a whole list of problems here for people, and one day, who knows, we'll make sure people do all of them, I guess. And number 4, you're back to the starting point. So in other words, we're going to have inverse cosine for number 4 of 0.678. So this is inverse cosine. So in the TI, again, second inverse cosine 0.678. So it's 47 point something degrees. 47.3 degrees here. All right. What's the next one? Number what? Number 5. What's theta going to be for number 5? It's going to be inverse sine 0.525 for number 5. Okay. So let's use the TI again. All right. So inverse sine. So second inverse sine 0.525, close, oops. I guess we have to delete that. Yeah. Go back, delete. There we go. Close the parentheses. And what'd you guys get? To the nearest tenth. What's your angle? 31 point what? 7 degrees. All right. Number 5. What's number 6? Inverse tangent for number 6. Inverse tangent, the decimal is 0.387. So let's see what this is going to be here. It's number 6, inverse tangent, using our calculator. Okay. Second inverse tangent, point what? 387 there. And so you end up with getting what? 21 point what? Is that 21.2 degrees? Number 6. Is that what you guys get for that one? Did I make a mistake? 21.2? Let's see. Did we make a mistake? Let's see. Double check. Number 6. You know what it is? No. 0.387? Yeah. Let me see if we... Right? You guys see what I'm saying? Is it maybe the highlighters help a little bit? So let's see, number 7 here is cosine, so we have to use inverse cosine, and then the number's 0.898 here. So for number 7 now, right? Cosine theta is 0.898. So how do we get theta? Use the inverse cosine key. .898. 26 point what? 1 degrees. Is that true? So what is 8? Sine is 0.122. So we're going to use inverse sine 0.122. So, calculators. Inverse sine 0.122. What do you end up with? What is this? 7.0 degrees. So, ladies and gentlemen, there you go. This is how you handle this question here. This is number 8. Number 7. So, so go through that, ladies and gentlemen, and understand that this is how you find an angle using the inverse function. I want to point out for example, let's look at number 13 here, okay? Number 13 is interesting. What should you see as an answer for number 13? We talked about it yesterday. 13 and 14 have the same answers. These are no solutions. Right, because cosine can't be bigger than 1 or smaller than -1. And neither for sine. So this should be no solution, ladies and gentlemen, for both of these, okay? Now, let's say you forget this fact, right? Let's say you forget and you go, oh my God, Mr. Judge, I'm using my calculator, because people forget, right? So for example, number 13, you might say, hey, theta is inverse cosine of 1.284, okay? Trying to find theta. And it's going to be the inverse cosine key. And say you go, you know what? You're going to use your calculator and you're going to punch that in. So we're going to get cosine, and you put 1.284, okay? And what do you get here? You get an error. And at least, here's the problem. This is error domain. And what that means is you're not allowed to use that number in what's called the domain of the function. The input of the function, there's a domain error. And it even says valued enters is not allowed in the function. And okay, that makes a lot of sense. You say, what do you mean that makes a lot of sense? Well, because cosine could not be bigger than 1. It can't be smaller than -1 either. And the same thing for sine. But what do you guys notice about tangent? So if you did it for sine, you'll get no solution as well. But what about number 15 for tangent? Just to give you guys comparison and contrast. You might think the same thing applies to tangent. It doesn't. It just applies to sine and cosine. So for inverse tangent, yes. If you said, I'm going to get this angle theta, you can. And punch it in. Notice this. We say, okay, second inverse tangent. I guess I have to clear that out first. Second inverse tangent, 1.682. And ladies and gentlemen, what do you get? 59 point what? 3 degrees. So that rule only applies to what? Sine and cosine, ladies and gentlemen. It doesn't apply to the other functions. Okay? Because what I gave you guys yesterday is this fact. I'll give it to you guys again. Number 1, part of our S is that -1 is less than or equal to sine of any angle, which is less than or equal to +1. Same thing for cosine. Sines and cosine live between these two numbers, but it doesn't apply to tangent. So yeah, look at the graph. If we go back to the graph, our whole graphing concept, right? If you go back and you go, okay, why is that, right? This is stuff I use for the calculus students. Why equals, for example, sine, right? Oops, let's get the functions here. Let's say y is sine, and they don't use theta, they use x, okay? Now, that's our sine curve. It's not a restricted domain. It's periodic. And I'm going to put y equals 1, and it's in red, and I like that. And usually there is there we go. Here's what I'm saying. You see this horizontal line? Right? It hits your curve for what values of y. The y-axis there is y between -1 and +1. You guys with me on that? And so, that's the range of the function. And then again, you say, okay, what about y equals function cosine? And let's get rid of the sine curve now. Notice the same exact thing. Okay, you're going to hit the value for sine and cosine between +1 and -1. That's the range of the function. But then you go, well, what about tangent? Well, tangent, the function is different, has a different domain and range. For tangent, take a look, right? Remember this, the tangent curves we drew? We only drew really one cycle. The range for tangent, ladies and gentlemen, it could be all real numbers. The range, all the y values, all real numbers for tangent. So that's why you can do this all day long. You go, what do you mean? They can say, hey, what is tangent? I'll put that as a note, just so you guys can understand that. You go, hey, what if they give me tangent theta is negative 32.187? Okay, can I get a theta? What angle? Yes, we can. We could use inverse what? 32.187. Okay, we're going to get an angle theta. Now, using our TI, we can say second inverse tangent negative now 32.187 here. So we get a negative angle, negative 88.2 degrees. Okay? And we'll cover this in more detail. But ladies and gentlemen, that's kind of what we get here for this. We can't do that for sine and cosine. If you say, what about sine? Well, it's going to give you no solution here. Say, what about our sine is going to be a negative 45.189 maybe. Well, it's not defined for that value. It's not in the range, right? It's outside the range of sine, but it's not outside the range for tangent. And again, it's the range of the function. That's what that is. What's that? Well, sine and cosine, the range is between, this is really describing what's called the range of the function. And you say, what's the range? It's a set of all y values for which the function is defined. Domain and range. And like I said, you can see the range really by simply looking at the function. It's always the corresponding y values. What happened to our function? There it is. Okay. It's all, and you draw this horizontal line where you hit the y-axis and the curve for those values of x. If we look at all those details, that's the range of the function. Same thing for cosine. That's the range of the values. And you go, well, how come tangent's different? Because it has a different graph. Yeah, the range is all real numbers. Where's the value? Where's the red? Oh, there it is. And you say, how do you know the range is all real numbers? Look at the graph. You hit, the curve for all those y values. You draw that horizontal line. That's really what the range is. It's all real numbers. That's the y values, the y-axis values. And this is an important detail, generally speaking.